Yeah, so today's topic is going to be how does MCS index help uncover Wi-Fi issues? First, briefly about myself. My name is Tuomas Aaltonen. I've been at SevenSignal over 10 years now, working as a senior support engineer in our support and services team. You can see a picture of myself on the right and some of the CWNA or CWNA certificates about myself. But let's get into our today's topic. So, what is MCS in Wi-Fi? And obviously, that's the abbreviation of the modulation and coding scheme, which probably most of you already knew. And here's some basics. How MCS is compared to data rate. The data rate in megabits per second. So what defines MCS is that we have two things, of course, the modulation and coding, and this will then tell us what the actual number, the index is going to be. So every MCS index has its own combination of modulation and then coding rates. So these are some of the modulation types that we use in Wi-Fi. So we have binary phase shift keying and different CAM modulation types. And then we have different coding rates. You can have like 50% of the bits used and then some more efficient coding rates as well. So those are the two things that then will tell our MCS index, and that MCS index is the number from 0 to 11 in Wi-Fi 6. So what then? Oh, sorry. Yeah, just forgot to mention that, but in Wi-Fi 7 there will be a new modulation type used again, so it will add 4K GAM. So that will bring more new MCS indexes and, of course, new data rates as well that clients and APs can use. These kind of don't have anything to do with the index itself, but they impact the data rates. So when we calculate what the data rate in megabits per second will be, we need to know what the modulation and what the coding rate is. So when we know the modulation and coding, then we also need to know what is the channel width. Are we using like 20 or 40 or 80 meg wide channel, or are we using short or long wide intervals? How many spatial size streams the clients or APs are using? And if we are using then Wi-Fi 6 and OFDMA, then we also need to know the resource units. Once we know all this, so we know the index and these four things, these four bullets, then we can calculate our data rate in megabit per second. You can see the formula there. I copied it over from the mcsindex.com. That's the formula to calculate the actual data rate in megabit per second. And this link also has this table, which shows all the different data rate combinations. I'm sure most of you may have even seen this or used this website to check out these different combinations, because it's showing all the different kind of possible data rate combinations and MCS indexes. So let's break down this to parts. So what does this tell us? So if we start from the left, these two columns tell us the modulation and the coding, and that defines the actual index. So for instance, if we take MCS 5, it will always be a 64 GAM with this coding rate, 2 out of 3 bits are going to be used for data. So two bits for the data. So if we see that the client is using MCS for then we know these two as well. It tells us the PHY. So the Wi-Fi 4, are we using Wi-Fi 4, Wi-Fi 5, or Wi-Fi 6? And these colors also help you to then check out the actual data rates here on the right-hand side. So these all are Wi-Fi 4 or 11N data rates. Here on the most right-hand side, you see the OFDMA as well. These are data rates for prior to Wi-Fi 6, and then you have Wi-Fi 6 data rates here. They have a little bit, these are a little bit more efficient. So the data rates are going to be, the megabit per second data rate will be a bit higher than in the prior versions of Wi-Fi. Spatial streams is defined at the left. You can see, well, mostly for the client, it will be either one or two streams, and you can see it's basically just doubling the megabit per second data rates, but all the modulation and codings will be the same. And then channel width broken down to different channels, and then the guarding the walls is one of the rows, and then here on the right-hand side is the OFDMA rates that will then continue. This is just the snapshot of showing most of the OFDMA rates. Sorry, OFDM rates, but not the OFDMA rates are shown here. But if you go to this website, you can check out the whole table. So it should have everything. But let's take an example. So if we think about just data rates, if we know that we have 65 meg per second data rates used by two different client devices, we can check our data rate table and see that these are different. There are different combinations. So if we just think about data rate itself, it tells just okay that a single frame is transmitted with this megabit per second data rate. But it doesn't tell us, for instance, anything else, because in this case it can be MCS 7 or 6 here, meaning that we have high MCS for a client that is using one spatial stream, or it can be also this one here, which is MCS 0 for a 2x2 client, and in this case it would be using 80 megahertz wide channel. So in this case, we know that our Wi-Fi link is actually stable and good. We can transmit with high data rate. That's what we care about, and that's what we want. And this, of course, raises some suspicions because something has, of course, happened, and the rate has dropped to almost the lowest rate. So it's actually better to know what the MCS index is rather than just the pure megabit per second rate, because that doesn't tell us much. I did this experimental test on my MacBook a while ago, and this MacBook I was using then in the test is a Wi-Fi 5 client from 2019. It's 2x2. Just to give you an idea how this RSSI and SNR values are impacting our MCS. So if we start here from the left, our signal strength is at around -65 to -60 or -65 it remains pretty good. So the green values are high, and then the yellow ones are kind of a fair, medium level MCS index, and then the red ones start to be a bit low. So you can see here that typically when the signal strength starts to be around -70 dBm, that's when the client needs to start use these lower MCS indexes, which is kind of a expected outcome, I would say. And that's why we want to design for certain signal level, certain signal strengths that most of our clients would have, like, better signal strength at -65 dBm or -70 dBm. It may vary depending on the requirements. So just to put like a general rule of thumb, you can think that, okay, MCS 0 and 2, these are kind of low MCS indexes, and typical signal strength range is from -70 dBm to -80. And then in the middle, we have a pretty good data rate already. So MCS 3 to 4, these are like medium level, and typical RSSI range is -60 to -67 dBm, and then 5 and 11 are those high rates when we have a good and stable link, and typically high RSSI as well. Of course, it may do even if we have like high RSSI, it doesn't necessarily mean you have high MCS, because you may have interference and other things that are affecting your MCS. So it's not always going to be the case. So it's not necessarily going to be correlating like this, but in typical scenario, it will. Here's just a snapshot of an experimental test again from an AP to my iPhone. This is iPhone 11 Pro, and you can see packet capture, and the AP and the iPhone are shown here. You can see the MCS used here, and then you can see retransmitted frames. So you can see that in the beginning of the capture, it's using mostly the MCS 6, and there's not many retries either, a couple of retries here and there. And if we go further in the packet capture, here we see a moment that we start to have pretty high retry rate already. So probably more than 50% of the rate frames are retransmitted, meaning that the client and the AP probably understand, okay, we must do something, and then it drops down to a lower data rate here. So it started with the MCS 6, but then dropped to finally using MCS 5, and which may then use like a bit more robust modulation type and coding rates to kind of pass that frame through the wireless medium. It's interesting that it was using sometimes before in between. I don't know why, but things are weird sometimes in the world of packets. Let's take another example from the real world. So this is actually these are different areas where we have been monitoring, and each bar here represents a service area, and it's an aggregated retransmission rate in these areas. And if we just draw 20% retry rate target, we can see we have one area where we have higher retries. So this kind of stands out from this chart, and it's 35% retry rate in total in this area. And if we compare that to an area with 6% retries, and if we look at the MCS table of clients, we can see in the 6% retry rate, we can see most of our clients are doing pretty well. They use high data rates always, so the high MCS index. indicates like good and stable Wi-Fi link quality. And only like a few times we see some clients dropping down to like MCS 0, MCS 1, but that could be expected to if the client is leaving building or roaming or something like that. But if we compare that to this site, which has high retry rates, it's totally different. You can see that the distribution of rates is much here on the left-hand side. So it's like clients, they may use MCS 7 and 8 and 9s a bit, but they need to drop always to the lowest rates as well. And that's due to the unstable Wi-Fi conditions. So these two kind of correlate with each other. So typically when you have high retries, you have also clients using lower MCS rates. And also vice versa, if you see low MCS is being used, then it's an indicator of high retries. Of course, one thing always to remember is that it's not the data rate is not the throughput what the client is experiencing. And I think for Wi-Fi engineers, it's easy to understand. But when we talk to people who are not that familiar with Wi-Fi, like if just some random person would use their network at home, they see this rate, they probably think, okay, well, I'm doing a 650 meg per second. I should be able to download and watch Netflix pretty well and do all the stuff. But in this case, it's not always the case. So it doesn't tell us the actual client side throughput. So it only tells us what the data is or the megabit per second data rate is for the actual one frame that we transmit over the Wi-Fi. So in this case, we have a solid rocking good Wi-Fi link, but still same time it may not meet our expectations. So what does MCS can then? How does it can help, or how it can help uncover problems? So this is table showing different kind of an issues or categories of problems, and it's kind of falls into these three categories. So if we see that client is using low MCS MCS rate, then typically it has something to do with one of these. So, or it could be a combination of all these three. So it may be experiencing low signal strength, or you may have a coverage gap somewhere, or you may have interference that's impacting the SNR, or sometimes it could be also a setting on your controller or your AP causing then potentially impacting like the coverage or something like that. But it may not always be the case. So it could also fall into this category. So all of the clients are kind of unique, so they behave differently. There are differences also between the same actual device model. So if you have two iPhone 11s, they may have different RSSI in the same spots. And of course, different client models have different antennas, and then there's also the factor of different Wi-Fi adapters and driver versions that may also play a role with your MCS rates. Let's take a look at the mobile eye. We do see here example from one of the devices. So device number 1. So we can see here that the 7 MCS, which indicates MCS index in this case, we see that it has dropped from the highest possible to 3. And same time, we see channel utilization being reported pretty high. So 72% channel utilization. That could indicate like interference possibly on this channel. And probably what has happened is that the retries have, gone up, and that's why the access point and the client had to negotiate like a lower rate to transmit, which then of course impacts our application or client side throughput as well. We can see that dips here after that change. So in this case, the client roams to an AP on a different channel with higher interference, and that's why the throughput and the MCS dips at the same time. Here's another example from another device. I think this is a good one because RSSI itself, it doesn't necessarily mean that you are doing pretty well, or the link quality would be great. So we can see in the signal line chart that our signal strength is stable. It doesn't change at all, but at the same time, client starts to use lower MCS index. Again, drops it to 3, which is not yet the lowest possible. It probably would be still okay for most of the use cases, but we already see here that something has affected the link quality. So there potentially could be interference or something on the channel that's affecting our MCS. And maybe this user is performing well, but you could also have 20 other clients on the same channel, and maybe 1 or 2 of those could be performing even worse than this particular device. So that's a good indicator of an issue here. So conclusions. MCS is selected based on the radio conditions. So it tells us, okay, if we have high data rate, we typically then have good Wi-Fi quality. And then if we have low data rates or low MCS index, that indicates that we have lower Wi-Fi link quality. So and potentially like Wi-Fi issues in that area. It tells us more about the link quality between 2 stations, and as we saw in one of the examples, the MCS index reacts with the small delay. So typically there's gonna be like retries before it tries to transmit with lower data rates or lower MCS index, and there's that delay between that change. So you need to have some retries before it starts transmitting with lower data rates. If we think about the MCS index as one of the key performance indicators, the pros and cons are there. So yeah, it's a best indicator for the RF link quality problems. And then it's simple scale, so from 0 to 11, so it's kind of easy to understand. Okay, you can break it down to like these three categories or 3 ranges: low, fair, and good. And if you have MCS 5, you get good quality, and 0 to 2 would be like the low MCSs. But also it doesn't tell us the client side throughput, like what it's kind of same with MCS index, like what the same problem with the MCS index, what we have in data rate, it doesn't tell us the actual client side throughput. But if we think about data rate itself, it won't tell us any of these either. So if we know that example from the 65 megabit per second data rate, it wouldn't necessarily tell us what is the link quality, or is the Wi-Fi stable, or it doesn't even tell us the client side throughput either. So the data rate in megabit per second does have that limitation. So in that sense, the MCS index works as a better metric to understand the link quality and how the Wi-Fi is working.